So, continuing the debug of the 8088 motherboard, what next? So looking at the motherboard, we can see that we have 640k of DRAM populated and they're all socketed. So it seems a pretty obvious thing to do to take out all the chips and test them individually and see whether there's a RAM problem, because it's often found with old computers that RAM chips die. So for this motherboard we can see that the 640k is composed of 2 banks of 256k and 2 banks of 64k DRAM chips, and there are 9 chips per bank. That's 8 data bits plus 1 chip for parity. So I'm lucky enough to have a professional EEPROM programmer, for want of a better name. It's a bit more sophisticated than that, and it's called the Speedmaster LV48. It can program a variety of chips, EEPROMs, flash, E2PROM, etc. But it also has an extra feature in that it can test chips. In fact, this feature I've never tried before, so this was an opportunity to see how well that worked. The Speedmaster has a nice feature in that it has a battery compartments, and if you put 8 1.5 volt cell batteries in there, it can be operated with no external power supply. However, I'm powering from my Rigol bench power supply. The cable that you see is a parallel port cable, and it connects to a Windows XP computer which is old enough that it can run the Speedmaster software. On the front of the Speedmaster is a standard ZIF, or zero insertion force socket, and the chips are inserted in there, and then you have to go to the software package to test the chip. It would have been nicer if there was a button on the front and you could press a button and you'd either get a pass or fail. So because the computer is on a different desk to the Speedmaster, it was a bit of a faff to have to insert the chip and then move to the other desk in order to run the software in order to get a pass-fail. So here's my Windows XP desktop, and I'm just launching the application. I'm now selecting from one of the main menus, and I've selected the menu for chip test, and here I'm trying to select the right chip. The accept button hasn't lit correctly, and after a few clicks and I finally decide what to test, the 256k, click on accept, and then from a menu above I can bring up this box here, which is the one used for testing. So this particular message often occurs, the check device position and selection. I don't exactly know what it means. I don't have instructions for the programmer, but my suspicion is it probably means the chip is likely inserted in the socket incorrectly. That's what it's meant to indicate. But in this case the chip's inserted correctly, so it most likely means that the chip is taking either too much or too little power, and the programmer's seen that as a fault. Any chip inserted into the socket should take some power, however little, and obviously the power supply will be protected from overload in case there's a short circuit. But it's an annoying message because it doesn't really give any diagnostics, but it means the chip is bad in some way. I do try and reseat the chip in case it's not quite in the socket correctly or some pins are not making contact, but when I see this message it's usually game over. So I'm testing another chip, and here we get a failure. It's failed at address 2. This one's testing correctly as well, and again it's failed because of reading the wrong data back. In this case it's got up to location 8k, and this is possibly indicative of an addressing error. So it may be that one of the address pins or the address circuitry isn't working correctly. So the first part of the DRAM is working, but then the address is screwed up in some way, and so it fails at this higher address. Again, the part tested, but again it fails very quickly. Again, one that fails quickly is a different address. Again, one that fails at a different address. So now I'm going to change over to the 64K DRAMs. Select that from the menu and bring up the test dialog, and its usual message suggesting something, device in socket wrong or some other problem. Few chips are like this. Then we have one that actually fails the RAM test. So finally, to demonstrate what a good chip test looks like, it does a couple of passes, zeros and ones, and then says the RAM's OK. And that's testing completed. So here's the final results from testing all the RAM chips. The 64K DRAMs didn't do too badly, but 4 of the chips out of the 18 were bad. I did mention I don't recognise the manufacturer of these chips. I don't recognise that logo, the M inside some kind of circle. The 256K chips fared a whole lot worse. There were 10 chips that were bad, and these are Hyundai. Now you might ask yourself, why do chips go bad? And I have to admit, I'm not 100% sure, because normally they only go bad when they're in circuit and subject to electrical stresses. So in the 70s and 80s and even 90s, DRAMs pushed process technology. The process node, as it's known, is a measure of the minimum feature size. The smaller the feature size, the more transistors or gates you can squeeze in the same area. And DRAMs have always been a way to actually push the process, because you're trying to get as much memory as possible. So it does mean that they're pushing design rules, and they're going to be more susceptible to long-term failures. However, the real reason for the failures, I'm not particularly sure. I believe some of the charges can migrate inside the chip. Normally this happens when the chip is operating. It can happen when the chip is overvolted or when it's stressed with temperature, but I do wonder whether some of those charges even can migrate very, very slowly when the chips are switched off, because this motherboard clearly hasn't been used for a long time, and that's an awful lot of bad chips. So what I've done is I've inserted one bank of 256K DRAMs, that's 9 chips, and in the next video I'll show what happens when I switch the board on in that new configuration.